So today we're going to get into our second method of how to solve a quadratic equation for its solutions. And the method we're going to be using is completing the square, but we're just going to do a partial introduction of how to start solving. We're going to wrap it up tomorrow. All right, as we have mentioned before, there are three ways to find the solutions to a quadratic, meaning how to solve for the values of x that satisfy the equation. First method is factoring. Remembering it's the fastest way. It doesn't always work though. I will talk about that in a minute. Second method is a quadratic formula. Always works, but we need to memorize this formula. And the third method is completing the square, which also always works. You just need to remember the steps to get to that. So again, factoring is already done. We're going to start completing the square today. Now, before we get into the actual reasons of how we do completing the square and solve in that fashion, we're going to talk about why do we need to learn another method if we already know how to do it with factoring. Like, why is this something else that we need to learn? Reason why is, let's say we take this quadratic right here and we want to go ahead and factor it. We set up our x factor, we put the 14 at the bottom, we put the 9 at the top, and we ask ourselves what numbers multiply to 9, add to 14. 9 times 1 works for the top, doesn't work for the bottom. 3 times 3 works for the top, doesn't work for the bottom. And that's pretty much it. Nothing else multiplies to give us a 9. That's an integer. So we're pretty much maxed out on answers. So in this case, this is not factorable. So I cannot solve this by factoring because I cannot factor it to begin with. So since I cannot solve this quadratic by factoring, the solution is not a whole number. That's what it comes down to. So the answer is not like a 7 or a 3 or -5. And it's also not a fraction like 2 over 3 or 5 over 7. The answer is actually some kind of crazy decimal number that we call an irrational number. So it's a number that cannot be written as a fraction or as a whole number. So it's something like square root of 9, square root of 7 or the square root of 13. So if you were to type those into your calculator, you'd get some ongoing decimal. So you're never going to guess those answers, therefore it's not factorable. So we have to have a second method to solve quadratics because factoring doesn't always work. So now that we've kind of gone over that, let's go ahead and get into the actual beginning of how do we solve a quadratic by completing the square. So for this first problem, I put like little spaces for us because we do have that 5 on the right side. We can move the 5 to the left, but it won't factor. So we're not even going to bother doing that part. We're going to go straight into completing the square. So we're going to choose a number for that blank that actually factors perfectly and nicely for us using a perfect square trinomial. So let's go ahead and do what we were doing before, which is figuring out, taking our 12. Again, we're going to split it in half. We get 6 and 6. And then we multiply to complete our square. So 6 times 6 gives us 36. So 36 will complete our square. So again, if you want to skip writing out the x factor and you can do it in your head, I can take 12, divide by 2, and say 6 times 6 is 36 in my head without writing the stuff on the right side. And that is perfectly fine. But if it helps you to write it out and see it visually, go for it. So I'm going to complete the square by adding 36 on the blank. Now, since this is an equation, I have to balance my equation. So whatever I write on the left side of the equation, I need to write on the right side as well. So if I add 36 on the left, it unbalances my equation, so I write it on the right side. So now that I've done that, I'm just going to go ahead and factor this. This is going to be 6 and 6 are my shortcut numbers. So we have x plus 6, x plus 6. And on the right side, now I have a 41 because that 36, which I added to the 5 on the right side, becomes a 41. And instead of writing x plus 6 twice, I can quickly just write x plus 6 to the power of 2. Now we're going to stop here, and we're actually going to finish this off tomorrow, how to get x by itself. But for now, we're going to just get this part started. Once you get good at this, the second piece will follow a little easier. And this is where the square roots are going to be coming in. All right, let's go to example number 2. So I'm going to ask myself, what's going to complete this square? Again, you can do it mentally, or you can write the x factor on the right side. So I know 18 is the middle term. It goes at the bottom. I'm going to split it in half so I can have 2 of the same number to complete my square. That's going to be -9 and -9. Make sure you put those negatives. And to complete the square, I multiply and get a positive 81. The square will always, the perfect square number at the top will always be positive. So I'm going to add 81 to the left of my equation and also balance it to the right side. And now I just go ahead and factor x minus 9 times x minus 9. Right side is a 74 from the combination of the 81 and -7. and I just write it as a perfect square trinomial now, and I'm done. Now, if you want to skip that second step, feel free to do so. So you can technically go directly straight to the answer if you do most of it in your head. All right, next one, number 3. Now, you're not going to get the problems with the little spaces in between like the previous 2 problems, like number 2 and number 1. You're going to see them like this. This is how they're always going to look. So you kind of have to make that space yourself. So we're just going to rewrite it and make that space. Now, if you don't want to write that underline, you don't have to. You can just write the number in. So we're going to ask ourselves, my linear term is negative 14. That would technically go at the bottom of the x factor. Half of that is negative 7, negative 7. And if I square it, I get 49. So half it and square it, whether you write it or you don't write it. Then we add it to the left, add it to the right. I'm going to use my shortcut, x minus 7, or I can just go x minus 7 quantity in the parentheses squared, and add the 7 and the 49. That gives me 56. So again, if you want to skip this step that just popped up, there it is again. You can skip it and go straight to the x minus 7 squared equals 56. Go ahead and try the last one and pause the video and then come back and check your answer. All right, now that you've done it, you should have the following answer. So we have 20 as our linear term, our middle term. If we take half of it, we get 10, and 10 times 10 is 100. Whether you set up the x factor or not, you're going to add 100 to both sides. Shortcut x plus 10, and on the right side you get 84. So final answer you should get here is x plus 10 squared equals 84. Now, as a reminder, we are going to be finishing these problems up, meaning we're going to take what we have here and get x all by itself. So the goal is to take this right here and solve it where we finally find what x is equal to. Remember, we have 2 solutions. That's what we're going to do tomorrow. We're going to take this quantity here, again, I'll highlight it again, and we're going to get the x all by itself. We're going to just use linear equation steps to get x by itself. All right, go ahead and finish the last page of your practice and get it marked off when you are done. Good luck.